The problem, how will you identify non-zero initial velocity? Read the problem now. A string of length L is fixed on both ends. Alright? So now itself all of you will clear that your length is L. Length is given clearly in the problem as L. But it is initially at rest in its equilibrium position. Alright? So the equilibrium position is given in the problem. So this question comes under non-zero velocity. In that equilibrium position, what is the function given here? 2x into L minus x. So other than nothing is mentioned in the problem. All the values are 0 automatically. Only the equilibrium position is given. So find the displacement at any time. Okay. Let's start the solution now. So we have identified the problem to be one-dimensional wave equation. Sorry, no. The one-dimensional wave equation is dou square y by dou x square is equal to 1 by c square dou square y by dou t square. Now, what is the solution for this wave equation? Yes, so the solution is y is equal to a cos px plus b sin px into c cos pct plus d sin pct. Take it as equation number 1. What are the following boundary conditions? The following boundary conditions are, so one by one we should write. Okay, according to the question. Y equal to 0 when x is equal to 0. Y equal to 0 when length is given in the question as L. Third one, y equal to 0 when t equal to 0, because all of you know that once again the value is given in the problem is 0, but the fourth one is given as an equilibrium position, dou y by dou t. The initial velocity is given in the problem as dou y by dou t is 2x into L minus x, which is equal to f of x when t equal to 0. This is the only change you can find when you compare your zero velocity. Okay. So right now, to find y of x comma t. To find y of x comma t. So that what we have to eliminate? Yes, sorry now, we eliminate A, B, C. For that, we are going to apply one by one the boundary condition. Okay, so we will apply first boundary condition first. Okay, write down. Apply boundary condition 1 in equation 1. Apply boundary condition 1 in equation 1. So 0 is equal to a cos 0 plus b sin 0 into c cos pct plus d sin pct. So once again what? Cos 0 is 1, sin 0 is 0, and C cos PCT plus D sin PCT is non-zero. So what is our conclusion? Yeah, therefore A equal to 0. Take it as equation number 2. Now substitute 2 in 1. What is it? Y is equal to, so A value is 0, so B sin Px into C cos PCT plus D sin PCT. Take it as equation number 3. So one constant is eliminated here. Now we have to concentrate for another 3 constants. Got it? So right. Apply boundary condition 2 in equation 3. So what are you getting from here? Y is equal to, what is the boundary condition 3? Y equal to 0 when x is equal to n. This is my second boundary condition. So I have to apply here. So what are you getting? 0 equal to, instead of x you substitute as n. So what I am getting? B sin P into C cos PCT plus D sin PCT. Already you know that C cos PCT plus D sin PCT is non-zero. Therefore, B sin PL is equal to 0. Since B is non-zero, sin PL is equal to 0. Yeah, 0 is nothing but in terms of sine function, how will we write? Sin n pi. So, PL is equal to n pi. P equal to what? N pi by n. So, we got our equation as 4. Got the fourth boundary condition. Substitute 4 in 3. Substitute 4 in 3 now. So what I am getting? Y is equal to B sin n pi x by n. So whenever we got an angle, we should write in this format. Angle into C cos n pi ct by n plus D sin n pi ct by n. Take it as equation number 5. So first boundary condition we got A0. Second boundary condition we got P equal to n pi by n. So what is the, still 2 more boundary condition is remaining. Okay. So right now apply boundary condition 3. What is the third one? Y is 0 when T equal to 0. That is the third one. In equation 5. Apply the third boundary condition now. So y equal to 0 when t equal to 0. So what I am getting there? Yeah. So y is equal to 0 b sine n pi x by n. So look at all of you here. Your t equal to 0. So what I am getting? Cos 0, sin 0. Okay. So c cos 0 plus b sin 0. So once again you know that cos 0 is 1, sin 0 is 0. So which constant vanishes? B value vanishes. So from here what I am getting? B sin n pi x by l c. Already we know that this is non-zero. B is non-zero, already know that. Multiply by the sine function. So from here what is our conclusion? Yeah, C should be 0. Take it as equation number. So previously we wrote equation number 5. Now my equation number is 6. Substitute 6 in 5. So what will I get it? Y is equal to B sin n pi x by n. So now my C value is 0. So what I am getting? 0 plus B sin n pi ct by n. So which is nothing but B into D sin n pi x by L sin n pi ct by n. Now you take the constant BD is equal to B. Once again, take the constant BD equal to B. So what I am getting? Y is equal to B sin n pi x by L sin n pi ct by n. So you know that sine is for nth series. Again sine is for nth series. The constant should be also for nth series. So right now, using the principle of superposition. Using the principle of superposition, how can you write? Summation n equal to 1 to infinity Bn sin n pi x by L into sin n pi ct by L. Take it as equation number 7. Take it as equation number 7. So 3 boundary condition is complete. Now what is the 4th boundary condition? We have to differentiate partially. So apply 4 in equation 7. What is my 4th boundary condition? Dou y by dou t is f of x when t equal to 0. So that I have to do it now. Right now. differentiating 7 partially with respect to t. So differentiate partially now. Dou I by dou t is summation n equal to 1 to infinity bn. So I am going to differentiate partially with respect to t. Without disturbing my x value, I differentiate only t. What is the differentiation of sine? Cos. Multiplied by what? The constant term. Okay, so what I am getting here? Sine n pi x by n into cos n pi ct by l into that constant. Into that constant. So now I am going to apply the T0, the boundary condition 0. So this is what is given, 2x into n minus x, which is what I wrote there. So which is summation n equal to 1 to infinity bn. So I will write the constant here, n pi c by l sine n pi x by l cos z. Because my fourth boundary condition is function when t equal to 0. So what I am getting here, summation n equal to 1 to infinity bn n pi c by l sine n pi x by l. Take it as equation number 9. Now the question is, we are going to find the value for the coefficient bn. So how the RHS look like? The RHS of equation 8. Equation 8 is half range sine series. The equation of equation 8 RHS is half range sine series. So first of all, write on the formula. Bn is 2 by L 0 to L f of x sine n pi x by L dx. Now in the question itself given f of x. What is the value for f of x? 2x. L minus x is given in the question. So we are going to find out the answer for Bn alone. But already Bn is multiplied by what? N by c by n. So when you are doing the calculation, you have to multiply this by n by c by n. Only in the LHS, not in your formula. Make it very clear. Got it? Yes? So we are going to calculate our value for Bn using Bernoulli formula. Okay? So Bn is n by c by n is. So I am going to write as per the problem. Look at all of you. As per the problem I am writing, because this is followed with the constant. This is followed with the constant. Got it? So that I should not disturb that constant. But everybody know the formula for half range sine series. So you do as per the procedure. Finally you multiply that by n pi by L finally. Okay? So that's what we are going to do. which is 2 by L. Yeah, 2 by L. 0 to L. 2 into, what is the question? Yeah, 2x into L minus x, is it? So, Lx minus x square sin n pi x by L d. All of it clear? I am going to expand the Bernoulli. Final answer I will multiply by this, or I will bring the term to the other side. So Bernoulli, everybody know how to do that. So take the 2 outside. Take the 2 outside. Apply the Bernoulli now, all of you. Lx minus x square. What is the integration of sine? Cos n pi x by L divided by n pi by L uv minus u dash v1 minus u dash v1 yeah, L square is not there, is it? X minus x square only, is it? No, question is correct or not? 2 into, no, question is correct. 2 into Lx minus x. Yeah, what you are getting this one? Plus minus 2 into cos n pi x by L divided by n cube pi cube by L cube. So integration of sin is minus cos by something, and keep on increasing your denominator value to get like this. Yes, apply now. 4 by L. Apply the upper limit and lower limit. So what are you getting? Which term will cancel completely? First one will completely cancel. Sine function also will get cancelled. So you are left with the minus 2 cos n pi x by L divided by n cube pi cube by L cube 0 to L. So what do you get here? Minus 8 by L minus 8 by L. Bring the term to the denominator. So L cube by n cube pi cube. Okay. Apply the limit now. Cos n pi, is it? L by L minus cos z. So what do you get? 1 L will get cancelled. Minus 8 L square by n cube pi cube. Cos n pi is minus 1 to the power n minus 1. Since we are getting a numerator of this form, we are going to consider for odd function and even function. N is odd, n is even. When n is odd, what is the answer you are getting? 16 L square by n cube pi cube. When n is even, you are getting 0. But actually, what is the answer we are going to calculate? Only Bn. Only Bn we are going to calculate. So what about n pi c by L? Bring the term to the other side. So what will happen? Therefore, Dn is equal to, so what is the final answer? N pi C by L is equal to 16L square by N cube pi cube. N is odd and 0, N is even. Yeah, 0 when N is even. Okay. We are going to find the coefficient of Bn only, not that constant term multiply. N pi C by L will go that side as L by N pi C. So multiply there and tell me the answer. Already outside, but 2 is multiplied. Yeah, because if you apply the upper limit and lower limit, L square minus L square 0, x is 0. Yes, therefore, so we want the answer only for Bn. So bring the term to the other side. L square by N cube pi cube multiplied by N pi C by L will be in the other side as L by N pi C when N is odd and 0 when N is even. So this answer will be exactly 16 L cube by N to the power 4 pi to the power 4 C when N is odd, 0 when N is even. So this is the answer for Bn when N is odd. Therefore, how will you write the solution? What is the equation 8? Therefore, equation 8 implies y is equal to summation n equal to odd to infinity. We should not write 1 to infinity because we are getting the answer for odd number of terms. Okay, 16 L cube by N power 4 pi power 4 C sin n pi x by L sin n pi C t by L. But the correct solution is 1 to infinity, not odd to infinity. So what will you do? If you want to get 1 to infinity, what will you replace? Replace n by 2n minus 1. Replace n by 2n minus 1. Therefore, what is our solution right now? Summation n equal to 1 to infinity 16 L cube divided by, instead of n replace 2n minus 1. Instead of n replace 2n minus 1. So you get sin 2n minus 1 pi x by L into sin 2n minus 1 pi ct by L. So this is the solution for our problem. So I will write down once again the solution. Y of x comma t is summation n is odd to infinity 16 L cube by n power 4 pi power 4 c sine n pi x by L sine L pi ct by L. But always our possible solution is from 1 to infinity. So replace n by 2n minus 1 because it is an odd number. So summation n equal to 1 to infinity 16 L cube by 2n minus 1 the whole power 4 pi power 4 c sine of 2n minus 1 pi x by L sine of 2n minus 1 pi ct by L. So this is the solution.